Okay, we'll do the next two together. So we've got fullerenes as the last two examples. So here's Buckminsterfullerene. This contains carbon. Again, each carbon is 3 bonds, therefore it has this delocalized electron because carbon should form 4 bonds. Uses for this, we've got lubricants and catalysts. Because of its shape, it's got a very large surface area, which makes it great use as a catalyst. This structure, remember each dot in here is a carbon, and the little lines in between are those covalent bonds between them. In terms of melting and boiling points, it's very high, so there's lots of strong covalent bonds in here and they take a lot of energy to break. Watch out, because this is lower than diamond, graphite and graphene, because this is going to have a molecular formula. So what you'll have here is one of these structures, and then another one here, and another one down here, and another one over here. But in between, you would have weak forces between those structures. And because those forces are weak, that slightly lowers the melting and boiling point compared to diamond, graphite, and graphene. In terms of the ability to conduct electricity, we've already said they have delocalized electrons, therefore it can conduct. But because it's this separate structure, this spherical structure, it can conduct on this surface, and if there's another one over here, then it would conduct on the surface of the molecule. It's very different to graphene, where graphene can conduct throughout the structure. This can only conduct on the surface of the molecule. It can't move in between neighbouring molecules. So it's a conductor, but not as good as graphene, as an example, or graphite. The other fullerene is linked into nanotubes. Again, it's carbon-based, 3 bonds rather than 4 bonds. Uses for this, drug delivery, sports equipment. Here's a picture, so it's folded up into a tube to give it a strength. Melting and boiling point is very high, lots and lots of strong covalent bonds, takes a lot of energy to break them. And the ability for this to conduct electricity, again, is very good. It's better than the Buckminsterfullerene, because the electrons can move throughout the structure and not just restricted to parts of this structure, as it is in this, which is just restricted to moving across this surface. Okay. Hopefully you managed to watch all the videos. Each one's a little summary of a type of bonding, well worth a listen to, short and snappy. Good luck.